Hello there, it's Heider here. Good to see you, or good to be here in a video at last. I have been extremely busy over the past, 6 weeks really. 3 weeks of that six, I had lots of stuff on the personal side, and the other 3 weeks I've actually been working on what I'm actually about to show you now on this development. So pretty much I've been working on the Texas Instruments processors, in particular one called the OMAP or the LCDK processor type, which is a development board. So I've got two processors with me, or two development boards. One is the OMAP and the other one the AM5728. So I think today we're gonna mostly focus on the OMAP itself. So I just wanted to show you what's it like to begin with. So this is the board we're actually talking about. It's a development board, so I'm just gonna zoom onto it more and just put it in highlight. There we go. So this is the OMAP system, or the OMAP board, and what it is think of it as a, I don't know if you've worked with Arduinos before, but think about it like Arduino on steroids. And what it is, this board has got a very fast processor. The processor underneath is actually Satara type processor. Satara is the ARM processor. But basically the board you're talking about, the processor of that is actually here. This is the CPU, and you've got a lot of stuff around it as well. You've got a network card, you've got a SATA, you've got a USB to I/O, basically USB for the serial, and you've got another USB for the host itself. You've got a USB for stuff to control like keyboards and other bits and pieces. Video out, you got audio in and audio out in here, and you got another audio digital VGA and a JTAG interface, and that is a GPIO, general purpose register port, or also pretty much used for display. The difference between this and good old Arduinos or Raspberry Pis is that this guy has got on this little chip in here, you've got a dual core processor, which is an ARM, and you've got also a DSP, digital signal processing system, or the DSP processor, which basically is a very advanced processor for the signal. Why you would use DSP, and the difference between the CPU is because a CPU works in serial. It does actually take stuff, process one instruction at a time. That's what CPU does. The DSP basically is it'll pick up an overall picture. It's like it's close to an ASIC, or also it basically I've got a lot of nicely integrated processing units to process what you call floating points, integers, and it pretty much in English it's actually used for really sophisticated signal processing. So for example, things like I want to calculate the sine x times cosine y divided by tan ABC, and all these x, y, z, ABC, these are all variables, and that DSP will actually work it out and then give you a really good result at the end of the day. So anyway, it's a bit sophisticated, but I think for the purpose of this video we're going to focus mostly on how do we get the processor of the Satara or the OMAP up and running, and what exactly do you need. Now the thing is, I've seen a lot of content online and videos online. They pretty much don't really help, because at the end of the day you sit down thinking, why is this not working? What did I miss? And a lot of videos, they will focus on someone developing stuff, but it doesn't show you the board itself. Others will focus on the board, but doesn't show you what can be developed. And a lot of videos from Texas Instruments have been created about what the capabilities of the thing, but this doesn't really help you in terms of, oh, actually I bought one, how do I use it now? Although this is called a development board, I wouldn't call it a development board yet, and I'll explain to you in a minute. So, without further ado, let's get on with the installation of the system. So now you're going to install the software. So basically, you download with the version of or as of today, 2022 June. The version of CCS is actually 11.2.0, so I'm actually going to download that now. Well, I already downloaded it and unzipped it, so here it is. I'm just going to start installing it now. You just run basically setup. It's really straightforward. I'll probably skip that video, that part where the installation is done. Right, so just pretty much straightforward. I accept the license agreement unless you really don't want to. You got a warning with antivirus check. This is standard, usual. You can go, make sure you've got your libraries all compatible and everything's saying okay apart from this file antivirus. Doesn't matter. Don't worry too much about it unless you have a different antivirus. So anyway, this is my folder I'm installing, so C/TI/CCS1120, and I'm happy with that. Yeah, you got asked custom or full installation. The reason custom is recommended because Texas Instruments does so many chips and devices and development boards and whatnot. So recommended is go with the custom installation. The reason, you'll see it now, all that stuff will come with it, and if you tick everything, it means you got all these devices, and I don't think anyone does. Also, it means you're a genius and you know exactly what you're doing. But it's just really simple. You don't need to tick everything up. So MSP430 we don't need. Simple Link we don't need. What I do need is the AM6, AM5X. Yeah, I need that because I got 5728. AM2, no. Sorry. OMAP, definitely. DaVinci video processors. Yes and no. I don't think I'll need it, but I'm just going to take it anyway. OMAP, definitely. The C6000, definitely. I need that. And what else? Yeah, I'll keep that. PGA sensor, no. UCD, yeah, I think this is fine. So I think what you really need is, if you're going to have an OMAP, you just use the OMAP in here, and also the C6000. The reason I've taken C6000 because the OMAP processor is a C6748, and you'll see later we need to install the TMS 320 C6748 processor, and that comes from this family in here. So this, you would really need to take that off. Multi-core DSP ARM, we don't need that one. C67, yeah, I don't need that one, that's fine. Next. It will come back, there we go. So, the Blackhawk digital probes, I need those, because I got ones. You would, well, Sega J-Link, I don't have that, but yeah, this one I do. And yeah, so next, well, this basically is another hardware. Just wanted to let you know in case you wondered. If you have a hardware that you use additionally to the development board in here, then you tick that. The hardware I have is this is the Black Hawk here, so this is the hardware there, and I'll come to that in a minute, but unless you have that hardware there, you don't need to tick that box over there, so that's fine. So we're just going to carry on with this next, and yeah, that is fine. Yeah, that took almost an hour to install, so it's all installed now. As you can see, create, launch desktop, blah blah blah. It'll launch the CS Studio. Good. Whilst I'm doing this, I just wanted to look into the device drivers just to be on the safe side. The ones we are interested in is probably the universal USB and the ports for serial and parallel, which doesn't show now because I haven't connected anything. Mind you, if you look at here on the board itself, we've not connected anything yet. The board is still powered down. This is just an audio. I'm assessing stuff with it earlier on, but that's not connected anyway. There's nothing there. Yep. Now, first time you use the system, it will ask you for the directory for the workspace. This is basically, I don't know if you worked with Eclipse or not before. Eclipse basically is a C, initially C, even Java you can do as well with it. But anyway, this is the workspace is the directory where your project will be stored and you utilize pretty much just where your projects will be stored, the master directory. I will be doing this on the D drive. Makes sense for me. I don't like to have it on the same PC. Where's it got my projects? Yeah, so I'll do it now. So I like this place, and I'm gonna take that to say, don't ask me again, just keep it in there. D projects CCS and launch that. Good. So now it's launching soon. Should come up. Should be fairly quick. Very good. Okay. Now, so we got the system coming up, the CCS. Great. We'll just pause it there for now. I'm not going to do much here anyway. I just want to show you the board to begin with. So here's the board we're talking about. You probably can see it. Now we're going to show you what it does, at least on the screen as well. So what it is, you've got a USB, sorry, MMC card, 32 gig. Well, you can, I have that, and the OS actually copied it there, and I'm just inserting it now. And basically, I'm going to connect the serial to it. So. And here's where a lot of confusion happens. So now the serial is coming up. And as you can see, now we have a new item which is ports LPT and COM, which is so on the COM port we've got FTDI manufacturer, the driver is FTDI, the 2.12 version .36.4. This is the one we currently have installed and we're using now. Now there's a lot of confusion on this, a lot, and when you get the board, you get it all installed, you think, hey, it's all working, I can now start developing things and using it this way. So let me just power on the board itself. So now it's powered on, and you'll see, well, you should be able to see the green lights anyway. Also, I'm going to launch Arduino. Where is my Arduino? Here you go. Yeah. Don't worry about Arduino. I'm not using Arduino as such or per se. Arduino I'm actually using because I have this serial monitor tool that comes with it that I want to watch what the serial does. So I'm not really using Arduino here. All I'm doing is the serial monitor there, and that's what I'm interested in. So if I go down, shut the system down, I'll just click reset here, this button. So when I reset, now I'm just going to take you back to the screen. You'll see now it's powering up. It's moving on, starting kernel, and now here you go, uncompressing Linux. So it's actually doing the uncompression. This is the board itself talking to the PC via the serial, and you can do nice, nice stuff with it. You can flash it up, do all sorts of wonderful things. Got a nice DSP to it, so I actually tried it. It's quite good. Right, so here we have the Arago project, which is basically the Linux, or the version of Linux that comes with the system, and it's actually all embedded on the SD card. Now, this is, as you can see, you can talk serial to it. For example, you can enter the root, and you can do, for example, things like -L. And you'll see here it's actually coming up with cd/, and you can see Linux is pretty much there, and you can talk to it and do all sorts of wonderful things like any other Linux does. This is all okay. Obviously you didn't buy it to just look at the Linux interface, you just wanted to develop stuff with it. So I think for the sake of this video, I want to show you what things can go wrong and how to fix them, as opposed to just saying here it is, the compilation, without doing all behind the scenes like some others. So let's take to the next phase. Now, before I carry on, it looks like there's an update available. I'm going to click there to get the update. I'm just going to install it first. I might just pause the video again and get back to it later. But I do want to, we should also do that same thing as well. Accept, obviously, and finish. So now what it's going to do is going to download this stuff from the internet and then install it at some point. Yeah, you can see here it's updating the system. It might take a while. I'll probably pause the video and carry on in a minute, so I'm just gonna stop recording for now. Yep, looks like the installation is now complete. It took about a couple of minutes, not really much. So it says restart now. Yes, go ahead, do that, and we're good to go. So as you can see now, everything looks there, looks nice and tidy. What I'd like to do as well, I'm going to install the VGA. I wanted to show you something else as well. So now the VGA is installed. It's there. Good. Now you can see yeah. So you can see now here on my other screen. Let me just show you the setup I have. So on this one, you see the last screen over there, where it says this bit. So here, this is the Linux booting up there, the Arago project. Also, I wanted to show you something else. It's nothing to do with this, but yeah, let's just go down to this bit here, back onto that. Yeah, so now I have the video coming up. Also the installation is still going on. Yeah, and now the CCS is coming up. Code Composer Studio is coming up there. Before I start showing you how to use CCS at some point, I want to show you something that everyone gets confused about. This happened to me as well, and I spent about a couple of weeks trying to really figure out what the hell's going on and why I can't do things that I wanted to do. So CCS is up and running now. Yeah. There's a lot of videos that will tell you it's there and you can use it, and also this USB port here, which I'm connected to my PC, is used to program the device, flash stuff, and do all the other bits and pieces. And you think, if that's the case, then it's definitely going to, I should be able to upload stuff to it and then use it that way. So let's try this here, and I'll show you how frustrating this can be when you don't know, obviously, when you don't have enough information on this system. So new project, new CCS project. Okay, so now here's my screen. I've got all the stuff I actually installed last time, all these devices. So if I do an OMAP, I can select any of those, but I would I'll do filtering at the moment. I just want to check something out first. Yeah, TMS 320, yeah, perfect. Okay, that's what I wanted to show. Right, let's go with this. So OMAP, and I'm going to do the LCDK, which is the L138. This is that board here. So I'm choosing that there. And I, the document says select XD100V2 USB debug probe. And this is where things gets really messy and ugly, because there's really hardly any documentation how this stuff really works, which I got frustrated with it for a bit. So anyway, so I've selected this. You click verify, and it'll pause for a bit, and it'll come back saying, no, I can't see the hardware there. Yeah, there we go. So this is the problem, sc underscore error underscore ftdi underscore open. This is the dreadful error because basically it's just saying I cannot open the device. And you keep thinking, what is going on? Why can't I open the device? I'm sure the device is absolutely fine here. I can read it via USB. Then you think, yeah, the USB, probably the port is open. Let's do something else. So you go back into, this is Arduino here, where we got the port open. I'm going to close this, and I'm going to close Arduino. So we now know that we haven't got anything talking to the serial, and I'm going to click verify again. And it'll be the same thing. So sc error ftdi open. Now I think the system, looking at the error message, is trying to open up something with the FTDI device. And then when you look closer at the motherboard, if you look where the mouse, where the USB is, down there, you will see this is the USB that we are talking to, right? And this is the device. If you zoom onto this with the microscope, it actually says FTDI chip on it. So you'd think this is trying to talk to the FTDI and there must be something wrong. I update drivers or do something. And here's what I've done. I've updated the drivers, no avail. I changed the, installed different version of CCS, going back to version 4, still the same problem. I installed Linux, 64-bit and 32-bit, have made no difference. I thought maybe Windows 7 32-bit would work better because sometimes Windows 10 have problem with the signed drivers. So I installed got another PC, tried to install it, and it didn't work. So it was all dead ends, just wasn't working whatsoever and at all. And I then opened up a case with support. Support was telling me all sorts of checks and stuff about the cable. But before I did support, I actually did something just to see, does the device work or is it a faulty device, that sort of thing. So here's what I've done, and this is something you might find interesting actually. So if I go back into a system in here I installed, which is the WinDSK, there we go, this one. So WinDSK is call it a third party company that developed something for it, just to show us what it does, or at least just to, it's like a little demo thing. Right, so I think I already have it installed. Yeah, I'll just, do I have it installed WinDSK? I think I do. Yeah, I've got it here installed, so it's already installed on my system already, so I don't need to go with this one. Yeah, I installed it already anyway. So here, WinDSK is this. So you got a lot of stuff that will talk to the processor, or to the OMAP. But before you can go that stage, I need to flash it up with the other kernel. So let's do that now. And I'm gonna go to DOS. Yeah, it's a bit slow responsive because I'm recording all this. Right, so if I that's the command to flash it up. I'll keep it up, but obviously WinDSK is, I would say, if you're going to download WinDSK and use it, make sure you get the old bin file to restore the firmware, because if you don't, you probably will brick the device. The problem with TI is pretty much everywhere that talks about the original bootable flash or the NAND flash have already gone. The site's been removed. Some companies bought the others, and as a result, you're not going to be able to get anywhere far unless you keep searching, which I've done, So anyway, I've spent about 2 or 3 weeks on this, trying to really get all of them. I just wanted to show you what happens when you actually use that. So let's just flash this up. Oh, to flash the unit, you need to change the dip switches on this. So I will need to change one. So 1 is down, 2 is up, 3 should be down as well. Oh no, sorry, up, not down. Beg your pardon. It's really difficult to. Hold on, 1 is off, 2 is on. Yeah, so we've got number 3 is up and running now. So exactly. So now the system says waiting to for the boot me signal. So if I click restart, yeah, let's do that again. So let's try to flash this one again. And now it's waiting for the boot me. So if I click reboot, there we go. So now, oh sorry, you're not seeing this. Let me show you on the screen. Yeah, beg your pardon. Let's do this again. So I'm gonna flash the system again. If I click this, yeah, so now we flash the system with the WinDSK image or the WinDSK boot. So to power up the WinDSK, I'll need to remove number 3 again and then put 8 down. Yeah. So 8 is to tell the system to boot from the NAND flash, and then halt. Well, it wouldn't halt the program, so that should definitely work. So if I reboot the system now you can see the light. I'll just show it to you one more time. Let me just switch my light off. If I boot the system again, notice here the light. See that? That means it actually is running the boot or the thing for the WinDSK. So if I go into WinDSK now and try to, you can see now all that stuff: vocoder, talk through, audio effects, KP, blah blah blah. And if I try to, for example, there's one I liked. Get board version. Let's see. So now you can get the board version here, and it actually will show it. So this is good. Reset DSP, host interface test, confidence test, save no. Scope, yeah. So you got all the stuff that comes up in here. You know, spectrum analyzer and all that kind of graphics. If I feed it audio, you'll see that stuff actually coming up here in real time, and it's actually quite nice. It's a quite a good nice to develop. So you really think this is? Let me just go through this one here. Audio effects KP. Yeah, guitar synthesizer. This is the one. So you gotta power up the guitar synthesizer and play song file. Actually, I don't know. I should play the play default. This is the one. So now this is working, and you won't be able to hear much because the audio is literally going to the HDMI, and the HDMI is actually off at the moment. But anyway, this is now playing like a MIDI file audio song, and you can change the parameters on the fly. So it's quite a nice thing to do, and you can see a lot of stuff like vocoder and the graphic equalizer and all that kind of stuff. That all audio, that's the DSP we talked about earlier. So it's quite a nicely developed system, and the beauty of it is actually running at 96 kilohertz. So it's quite a nice thing. So you can imagine this OMAP thing, or this OMAP motherboard is a really sophisticated sound card, and if you can drive it well, you would obviously be able to create your own instrument. And this is basically what's used in the Kronos system. So the Kronos uses that OMAP and developed in 2011 or 12. But the programming on this is the code, which I will come to work on this later on in a different video. But for now, I just want to take you through the OMAP. So anyway, back into this thing. Now you think, if I can flash the system up, why can't I connect to it from CCS and develop my code? And this is what a lot of people thought about, and they just can't get it. You know, what's going on? And for some reason, with Texas Instruments, they sell in this as it's a development board, but there's a missing ingredient which you don't really get with it, and this is where the problem is. So let's go back into the original firmware. So I'm gonna reset it back. So I need to switch off 8. And then switch on 3. And then go to boot me. Yeah, so now loading the original firmware back in place. The reason I do this, because the original, or the one I just loaded now, it actually overwritten the boot code, or the boot sector, the boot partition, whatever you want to call it, on the NAND flash. And now the NAND flash will only power up the WinDSK. So it's like you're powering up things, powering up the WinDSK part, and it's ready for you to process audio and do DSP stuff. But the downside is it will no longer power up anything of the SD card. So you pretty much lost Linux, lost the rest of the stuff. You can't develop with it, you can't do anything with it whatsoever, and that's because of that. So this is now, we're back in place. I'm gonna switch off 3 again. So now the system, so the switches are 1 is down, off, 2, 3, 4 are on, and then 5 to 8 are all down. So this is, you know, obviously you can download the stuff online to get what it means, but Texas Instruments has got a lot of nice resources you can actually read and understand. But there's a lot of it. You know, it took me two or 3 weeks to actually understand what the system is doing and talking about. So there's a lot of documents to read and all that kind of stuff. So anyway, now let's go back into the USB. So let's pick up Arduino. And what I do like to do is just check the port just to see if it's going to actually boot up Linux or not. So tools, serial monitor, and we'll just wait. So I'm just going to reset the system now, and here we go. So now it's actually coming up. By the way, I made the font slightly bigger so you guys can see it, the 125 scale. Yeah, so now it looks like we're in. So it's reading up all the BIOS stuff, starting UDEV, and you can see now the other one. I don't know if you can see the other screen. The screen now is powering up, and now we're moving into boot. So now people think, if I can flash the system and talk serial to it and do all sorts of nice stuff with it, why can't I develop? There must be something wrong. And that's the trap I fell in myself. So you're going to close now the serial, I don't need to do it because I want the system to actually talk to it itself. So now I go to File, New, Project, and I'm gonna do OMAP, and I'm gonna check the LCDK OMAP 138, L138, right? And I'm gonna say test 1, whatever you're gonna call it. The debug probe is going to be the XDS 100 V2, which is a Texas instrument. I'm gonna verify, and it's gonna fail, right? So as you can see, SC error FTD I open. It kind of just, it will not open it. Just doesn't know what to do. So now I've actually ignored it and said, okay, stop this. I'm unable to connect to it, so I'm gonna go in anyway. Right, so I've created a new project, test 1. Yeah. There we go. So now that's my new project up. And if I just do things like include stdio standard.io.h, and I'm just gonna print here Heider's test 1, 2, 3, whatever. Right, okay. So now I've got my code. No errors so far, so if I'm going to compile it here, just click that. It will compile. So the build is finished. Looks all good, no errors. That's to include the standard I/O, and this is to print because I'm actually going to do standard I/O. So this is fine. Now I'm going to run it or debug it. So debug as CCS, and here's the problem. It's just not going to load it. Now we'll see. Going to do the thinking, launching the debug perspective, trying to get into the brains, so the deployment, nice, all good so far. Here we go. So one of the FTDI driver function used blah blah blah, returned an error. It just wouldn't connect. The error message is here we go. The XDS 100 cannot be located. Just can't find it. It just wouldn't talk to it. And you think, looking at this, you need FTDI, but FTDI chip is actually here on the board. Why can't you talk to it? And you know, this what took me a long time to actually realize. There's something wrong. So when the guys in TI support came back, I did raise the question because we were going down the loop, and I said, well look, it's not clear from the system why can't I install it there, because it looks like to me, do I need another device to talk to the system? It looks like I need a JTAG to flash it up. JTAG interface is actually this little port over here. So that's where the JTAG is, and the guy said, yeah, this system does not work with that JTAG. So this was, and going back to what we said earlier, it's a development board, yes, but you cannot develop with it anything, as you can see, because it's missing the main ingredient, which is the development or the debug probe or the JTAG probe. So that's what you need to get with it to make the whole thing work. So to do that, this is what you need, and this is called the Black Hawk was another Texas Instrument XD100 emulator. So you need this here. I can see it. So here is the one, and you need to plug that into the JTAG port. And believe me, this has nothing to do with that serial. So what we're going to do now is, let's just power this off. Be safe then, sorry. Connect. By the way, the connector on the JTAG port will have a little, usually it will have a little dot over here. Make sure the third pin, which is the dot, is actually in line with that little thing over there. So this one, you can see here the pins are all there apart from that. Number 3 is missing, and there's a reason, because you know they're trying not to make sure that you don't put the cable in the wrong way. If you do put the cable in the wrong way, you could cause serious damage. So just really make sure that you get this right before plugging this in, right? So now this whole thing is inside. Perfect. And also, to let you know, you can use that here if you want to. Sorry, you can use that here if you want to on this one. Or you can use both serials. So what I'm going to do, I'm going to use a second serial connector to go into this one. Now, whilst I'm doing this, notice Device Manager open currently at the moment. Yeah. Actually, I should have waited. I wanted to show you something before. Yeah. Now, here is what comes up, and this is what we just plugged in. It goes into the Texas Instrument debug probes. That's what the system is looking for. So the XD100 comes up in here. So don't waste your time trying to fiddle with this serial port and also that serial converter. It's a waste of time. You will go nowhere, and it's not the device you're looking for. The system is actually looking for these two devices, and these are what connects into the programmer in here. So this is literally the programmer as a JTAG. So JTAG basically is a protocol used to freeze the CPU, load up stuff to the memory, and tell the CPU go there, run it from that side. And this is what, you know, make things happen. So that's what you need on that side. So now we plug this in, and I'm just going to unplug it for a bit. Just want to show you one more thing before we carry on. So I'm going to power up the system. I'll let it power up and then carry on this way. Actually, because now we are going to use the second serial port, so I'm going to go back to Arduino and just look at the board output, because now we can. We're not going to use it to develop with it anyway. Yeah, so tools, serial monitor, there we go. And I'm going to do another reset just for the hell of it. There, so now it's restarting, and it's actually coming up nicely with all the wonderful bits. But that's not what I want to show you. I'm in, where's my DOS? Did I close DOS? Yes, I did. CMD. Yeah, thank you very much. Now, to find out if your device is correct, and this is something you need to do if you are a developer, well, if you don't know why your system cannot really deploy your code anyway, this is what you need to do to find out what's going on. So you go into your TI installation, you go into CCS, CCS again, CCS base, and you go into common, and you go into the USCIF. This is the directory you need to be in, and you need to run this tool x100 serial or xds100 serial.exe. So run that one, and now that will tell you what you need to know. No XDS emulators found on the system. This is where the problem is, and it took me a while to actually, because I kept fiddling with the other, with the USB to serial, and when you install your normal board without the JTAG, it will install this and it will install that, and we talked about this earlier. But you're thinking in your head, I can flash the device, I can deploy stuff, talk to it via this port because it doesn't need it for application. This is actually literally to talk to the FTDI port on the site, but then I just cannot deploy any code, and this is the problem, and you just fall into that trap and thinking, how do I get this to work when actually it's nothing to do with it. So now we're back into this one. If I plug this in, so now my FTDI, my JTAG, sorry, is actually now coming up. So text instruments. Now if I run this again, the serial, and here you go, voila. So well, hey, you got the thing installed and it's now operational, and now means I can actually talk to it. So going back into my project in here, and if I go into, just do this again. Let's just run this one more time. Right, so there are two more errors I want to show you as well whilst we're working on this. This is one of them. There's another error you'll see. Yeah, exactly. Load program error. But the reason why we have in this error, well, let's just see what the error is to begin with and what we need to do about it. So let's just take it there. Trouble writing to memory block. Let me just make the screen slightly bigger because this is not, it's unusable like this. Yeah, that's good. Now, here is the error message. Trouble writing to memory block at 8000. This is the middle of, well, whatever memory. Is a version memory. Length that. File error, verification failed. Write to this. GL file is that. Load failed. So it's just failed all over the place. But the good thing is, it's talking to it. So it's trying. Now it sees a device. It's trying to talk to it and then think, no, I can't just do this. Anyway, going back into this, into my project properties. We'll come to that error. We'll solve that error in a minute, but just wanted to confirm the system. Does it work or not in exactly the same way? So if I go into, where is it gone? What am I looking for? Yes, sorry. This is the guy. No. What am I doing? No, not you. Sorry. Yeah, so view, and you're looking for target connection, target configurations. That's what I'm looking for. And that's the bit that failed earlier. So if I right click, properties, this is why we were created earlier on. Double click, sorry, not right click. Yeah, and now you can see the screen that we had earlier. So let's just take those two down. Yeah, so here that's the bit we done earlier today, or just a minute ago, and the test connection, well, we tried that earlier on, that didn't work out. So now you can see when I click verify, it comes up with all the wonderful stuff and it says nicely has succeeded. I'm just going to show you that again as if I'm creating a new project. this will make more sense, because obviously I want to take it to the exact same steps we did. So new CCS project, okay? And what we did earlier, we said OMAP, right? And we did this, and I've done whatever blah 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 test. I'm not going to save it yet. And what I've done, I've selected the XDS 100V2, the USB debug probe. And when I clicked verify, it said I cannot open device, and that's the bit we were stuck at. Then I actually clicked bypass anyway. So verify now, and you'll see this will work absolutely fine, flawlessly, as if, yeah, it's there, I'm fine. So there we go. Succeeded. No errors this time. And this is when you install that bit. But it's not the end. It's not the happy ending to the story yet. So this is now part one. Now the system can see it. So now the system can see itself and can see the board, but it just cannot deploy. And the reason for that is because, by the way, there's a bug when you click verify. I'll just show that to you again. There's a bug on the interface. When you click X, it just doesn't close. I need to click finish. I don't know why, but that's fine. Anyway, so I'm going to cancel that bit now. So the reason why you cannot deploy to the system is because the system is powered up using Linux. And I know it's a PC or Intel stuff, processor stuff, but I thought maybe the Linux that's booting on the ARM processor is locking up the memory and then restricting the BIOS running in protected mode somehow. So I thought, if I power down the system and then run it again, would it work or not? To do that, I'm going to eject the card for or the SD card. So now I ejected it for the Linux operating system, and I'm going to reboot the system again. So when I reboot now, you can see it's rebooting, but now it cannot get the kernel. There's no disk, we just ejected it, and now it's actually at the U-boot prompt. So now it's waiting for, it's like a blank paper that does nothing, there's a little break. Now, if I go back and run my code again, if I just run, debug the code one more time, so now it's going to go away and then try to do it again. She's now building, up to date, build finish. You'll see it now is working. See now? The error is gone. And it's quite nicely. The system now, so you can see these three are disconnected, but the ARM processor is connected to the debug probe, right? And now the code is running, but is actually at the breakpoint in here. So this is the signal that tells the system stop, don't execute, just wait until the user does it. And this is because I'm actually debugging the system. So if I click on, just wanted to show before I can use the what's it called, the key. I want to show you here. So if I click on step over, which is F6, right? F6. Yeah, so now we're stepping over F6 again, and now you can see it's printing the stuff as we like it. And then if I can't, we just click resume all the way, and it's done. So you can see now the ARM processor has printed my code as 1, 2, 3. So that kind of tells you the whole thing is actually working. It's flawlessly working, nothing wrong with it, all because of that little probe. That took me a couple of weeks to actually realize that it is the problem. Similar problem we have on the other I'll take it to the other system and how to install it in a different video. But another thing you need to know when you do that kind of stuff. So let's just go back into the CCS editor perspective. No, I went back to the debug. Damn it. I don't want to do that. Sorry. Yeah, that's it. So, in your edit, when you click View and you ask for target configurations there, it will come up on here. So this is target configuration, and you'll see your stuff with the same project name that you created, literally. So if I go into right click, set as default, you need to do that to whenever you run, you're actually going to go into this default in here. So now it's black highlighted. And I also like to do sometimes the linked file to projects, but that's not necessary. When you need to debug the, if you want to break the system and debug it halfway, you can do that. That's a different thing to do. So I'll show you one more thing. So if I put the card back in, reboot the system, right? And now it's rebooting it. So if I'm going to click launch selected configuration on this one here, you right click and you launch selected configuration, you'll see the 4 probes come up. So now the system is ready to be connected to, and then do stuff to it. So if I right click on this one and say connect to target, now you can see it will allow me to kind of break that process down, halt the CPU there. So now the CPU is now broken at this address. So this is where Linux is running halfway through. Then I click view disassembly. And here we go. Yeah, so you see that now? If I just move that slightly here, you'll see nicely. So all the code, all the assembly, the machine code or the assembly language running on the ARM processor is all here. So this is all there for you to see. And you can actually, slowly trace it, bit by bit. You can just use the F6 key to, run through the code, and then it'll take you a week just to click F6 and go through every single thing. Well, no, it'll take let's say a long time, not a week, so I just exaggerated that. You can you can do it in about an hour or two. So you just click F6, keep clicking F6 until the whole thing boots up. So we can say resume, and resume booting up. So there we go. Now Linux is booting up until the Argo project comes up, and it's there. So I hope that video helps you if you wanted to get started on the OMAP processor. It's a nice world, really nice to begin this way. And I'm going to use that system now to build up the other project that I'm actually working on the Kronos. So this is something I'm going to pick up and load up with the code that I'm actually working on, and obviously take it to the next level. So let's see how that's going to go. So for the past 2 or 3 weeks, I've been pretty much stuck on this bit, trying to get this whole thing working. And also, I've got the other processor in here, which is that one as well. Same thing. I will make another video on how to do the development. So similar thing really, you need to install the JTAG, but the JTAG is a slightly different interface and that sort of thing. So anyway, so I hope that video kind of gave you a nice insight on what's going on and how things working. So hopefully you find it useful. It's lovely when the camera does that. Yeah. Hope you find it useful. So thank you for watching, and have a nice day. And I'll probably we'll talk soon. See you later.